Alright, so in this equation, I'm going to be solving 9 to the power of x is equal to 36. So to start, my variable in this equation is x, which is what I'm going to be solving for. And we can already tell that x is not going to be a whole number because 9 to the power of 1 is 9 and 9 to the power of 2 is 81. So we know that x is going to be somewhere in between 1 and 2. So we want to find the exact value of x. So to do that, what I'm first going to do is take the log on both sides. So I get log 9 to the power of x is equal to log 36. And the reason I used logarithms for this is because they have a special property that states that if I have something in the form log a to the power of b, I can move this exponent b to the front, so this turns into b times log a. So before, x was an exponent, and it's almost impossible to solve the equation just in the form x is. But now we can move x to the front and make it equal to a whole number, and now it's much easier to solve for x. So now I get x times log 9 is equal to log 36. And now, obviously, we want to isolate x, so I'm going to divide both sides by log 9. So then these two cancel out, and I get x is equal to log 36 over log 9. Now, we aren't done yet because we want to find the exact value of x, so we don't want any logarithms in our solution. So now what I'm going to do is I'm going to rewrite log of 36 as log of 9 times 4 because I just want to simplify log 36. And now I can use the property that states that if I have something in the form log a times b, this is equal to log a plus log b. So in this case, I have log 9 times 4, and we can say that a is 9 and b is 4. So this turns into log of a, which is 9, plus log of b, which is 4. And remember, I still have all of this over log 9. Now, if I have something in the form a plus b over c, this is equal to a over c plus b over c, and this is just using fraction properties. So I have log 9 plus log 4 over log 9, and I'm going to rewrite this as log 9 over log 9 plus log 4 over log 9. Now, anything over itself equals 1, so log 9 and log 9 cancel out, and I get 1 plus log 4 over log 9. Now from here, I'm going to simplify this by rewriting log 4 as log of 2 squared, because 4 is equal to 2 squared. And I'm going to do the same thing to log 9. I'm going to rewrite it as log of 3 squared. So now remember that if I have something in the form log a to the power of b, this is equal to b times log a, because I can move b to the front. So I'm going to be reusing this property on these two terms. So log 2 squared, I'm going to move the 2 to the front. And same with log 3 squared, I'm going to move the 2 to the front. So I get x is equal to 1 plus 2 times log 2 over 2 times log 3. And now I can cancel out these 2's. So I get x is equal to 1 plus log 2 over log 3. So now from here, log of 2 is equal to 0.3010, and log of 3 is equal to 0.4771, meaning x is equal to 1 plus 0.301 over 0.4771, which is equal to 0.6309. So 1 plus 0.6309 is 1.6309. So this is my solution. Alright, so in this video, I'm going to solve the equation x to the power of 3 minus 8 is equal to 0. So how most people solve this equation is they add 8 on both sides. So I get x to the power of 3 is equal to 8. And then they take the cube root on both sides. So the cube root of x to the power of 3 is x, and the cube root of 8 is 2. So then they get x equals 2, which is a solution to this equation. But actually, there are more than one solution to this equation. So I'm going to rewrite my equation here, x to the power of 3 minus 8 equals 0. And now I'm going to rewrite 8 as 2 to the power of 3. So I get x to the power of 3 minus 2 to the power of 3 is equal to 0. And then now I'm going to use the formula a to the power of 3 minus b to the power of 3 is equal to a minus b times a squared plus ab plus b squared. So in this case, this turns into x minus 2 times x squared plus 2x plus 4 is equal to 0. So now I get two equations. I get x minus 2 equals 0 and x squared plus 2x plus 4 equals 0. So for x minus 2 equals 0, I get x equals 2, which was a solution that we already got. But now see, on top of this, we have a whole nother equation with 2 more solutions because it's a quadratic equation. So to solve this, I'm going to use the quadratic formula. So I get negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times a, which is 1, times c, which is 4, all over 2a, so 2 times 1. And this turns into negative 2 plus or minus the square root of 4 minus 16 over 2, which is equal to negative 2 plus or minus negative 12 over 2, which is equal to negative 2 plus or minus 12i over 2, which is equal to negative 1 plus or minus 6i. So these are the 2 more solutions to this equation.